But Ali, if we continue with the printing, as you described in the end here, we have some questions around that. For example, the printing paste you mentioned is for screen. What about digital printing?
They can be used, more or less for also digital printing, right? So the thickening, actually, let me go. I have some backup slides for here. Here we go. This is waterless digital printing. So they're using pigments, and they have claimed actually that this will reduce water consumption to 50 liter per meter of the printed fabric. So that formulation can also be used here. So there is no limitation for using also pigments for printing like textiles here. And as you can see, this is a large machine, so the length of nearly I think it's more than 3 meters.
What about purely water-based formulations for printing? Do you have solvent or?
Yes, there are some as well that they're using reactive dyes, especially that with they're formulating them with some paste to keep them in solution for a long period. So the only issue with those printing machines, that actually we have one here in our department, is that the shelf life of these ink that is provided. So normally 6 to 9 months after, if you're not using, we should change them. And so the thing is that they cannot be used, for example, for polyesters, right? On contrary to what you can use here. So pigments, actually, they don't have substantivity, and they will remain on the surface. So they can be used for any type of fabric, and no matter if it's like cotton or polyester. But here, for example, if you're using like digital printing as well with like ink that they contain reactive dyes can be just printed on like limited like a number of fabrics, for example, nylon, cotton, wool, and so on. Polyester is not a good choice here, right? So because it doesn't have any reactive dye size that the reactive dyes can actually react with. Therefore, the limitation here is the shelf life of the ink and the formulation as well. And the other thing is that after printing, the fabric should be steamed for fixation to happen, to be completed, and then it should be washed. Some of those colorants that they are not fixed in place, during the washing, they will leach out. So what is very important here is that during the printing process, what they claim here is right. They don't actually, the water consumption is low, energy consumption is low, but they don't say what will happen after that. You should wash these, right? Even if it's pigments, if they're printing, there are some remaining that it should be washed. So whatever is not fixed on fabrics, it will be washed away during the washing process that is following the printing.
So we got some a question here then. So I've been told that the digital printing takes so much water in the pre and the after treatment of the fabric. So in total, it does not save so much water. Is that true? So as you mentioned then.
It has its downside, but however, what they're actually comparing is what is available in the market, or the dyeing process, that it needs lots of water. Yeah, they compare, and then these are like claims saying that the water consumption it's a lot, 15 liters per meter. But if you consider before and after, we still have washing process before and washing process after printing. So the only thing that it will be saved here is the amount of dye that is needed during the printing process. So this is one concern, that you should know, that for having preparing the fabric to be printed, we have strong washing, especially if it's cotton. So it has wax, it has dirt, it has polymers, sizing agents, and they should be removed. So overall, it doesn't change the whole picture that much. But these are emerging technology. So what the picture that you see, I think it was from ITMA 2019.
Thank you, Ali. One question more related to the printing. What about the binder? Will it be washed out? And what does it usually consist of?
Binders are normally monomers, acrylic monomers. And so the process, the formulation that I showed here is actually, it comes in two parts here. So the binder normally they will not mix with this part. So these are in two parts, and just before printing they will be mixed together. Otherwise, this binder is a monomer that by catalyst it will start polymerizing. So this is a sort of emulsion polymerization, right? So they mix these two, and that monomer during inside the emulsions on the interface of the emulsion starts binding together and make this film. So this is a polymer. So these are monomers that they will turn into polymer, and they remain on the surface. So these are like a glue. They glue the pigment or dye to the surface of the fabric, right? So what will happen here is we have volatile content, so air pollution here a lot, because this white spirit or oil and water during this curing will evaporate. So we don't have water consumption, but pollution, but we have air pollution there.
The VOC.
Yes, we have VOC. So quite high actually for the printing.
All right, let's continue here. The next one, what new developments within dye technology, but also colorants itself, even if you said that they are not too toxic, are being implemented today that will increase sustainability of textile dyeing in the short term? And what developments are on the way for the long term? Could you elaborate a little bit on that?
About the textile, colorants development, it hasn't been that much development, because as I told you, from 1860s, there are millions of structures have been synthesized, and the best of best, the one that actually they had very high wash fastness, light fastness properties, they emerged. So we had let's say 10,000 to 15,000 good commercially available colorants. So the reports that you see here is from 1980, so it's pretty old, right? So many of these, probably in these 3% that you will see here, they have been phased out till now, I'm sure, right? So because of the increasing awareness towards environment, aquatic toxicity, and so on, so the colorants that they have high toxicity, gradually they will phase out. One problem it remains, it's a price. And many of them, perhaps for example, sulfur dyes, metal complex, these are actually very cheap, or they can be produced very cheap. And compared to what is available, the reactive dyes are now, they are in high demand, and the share in the market has increased. So compared to them, it's still cheap, so they will use it in China, India, and many other countries around them. And so that will reduce the production cost. So development in that sense that we will see new reactive dyes in the market, no, but that's something that actually I'm working on at the moment. So we are going to develop a new generation of reactive dyes, but it's in research level, so it hasn't reached to be commercially available. And you know that it's very difficult to introduce a new colorants to the market. It needs lots of investment and research. And now that it has reached, the market, it has reached the maturity. Out of these 10,000, 15,000 colorants that are commercially available, they have taken the best of best with very high wash fastness, light fastness properties, and they remain. What was the second part of the question?
It was more elaborating around the short term and the long terms. But I was thinking, Ali, thank you. We can talk about the coloring process on its own, but that also requires quite a lot of chemicals in the pre-treatment process, right? And also in the finishing process.
Yes, quite a lot.
Maybe you can just elaborate a little bit around that. And as you mentioned, it's difficult to change one chemical to another or a dye in the processing today, because many of them are trying to be continuous, right?
Yes.
And trying to change from dye to another, it's quite complex. I was thinking maybe you can elaborate a little bit about the pre-treatment process and
that's another presentation by itself. So.
I understand that. But the pre-treatment processes, generally, what chemicals are used there, for example?
Yeah, so I will show you. I mean, that's actually the course that I'm going to teach next semester. Perhaps you can invite me again fall semester. Then I will brief you about, maybe I will have a crash course on the chemicals. But I mean, I prepared this, for this session as well. So you see, for turning yarns into finished fabrics, so this is the slide that you have already seen. So we have many processes. So the warping process is like mechanical, perhaps, but before weaving, we have a sizing, right? There is possibility that, for example, for denim also we have dyeing process here. So this is called sizing. Why do we apply sizing? So we have like polymers, starch and so on, because weaving process is a mechanical process and there's so much tension on yarns, the warp and weft, there are so many mechanical. So they may break during the process and they reduce the speed of fabric production. To prevent that, you are covering a layer, a coating around the yarns, and those are mostly like polymers, water-soluble polymers. But however, those are like impurities. So especially they have very high COD and BOD because some of them are also biodegradable, but they are increasing also the pollution. So they're adding so many chemicals here. So that's called like sizing agents. And before here, number one, if it's a synthetic fibers or not, for example, for synthetic fiber, we have a series of like chemicals that they are used there, correct? And then after weaving process, now it's contaminated with sizing agents, polymers, dirt, oil, and so on. Now we want to do dyeing process, but that cannot happen because if there is any remaining oil or wax on fabrics or yarns, then it will interfere with dyeing process. Then you will have a part that they are not dyed, or it will interfere badly with the dyeing process. So they should have very thorough cleaning process that is called desizing. Now they have developed some green process like enzymatic treatment that they will actually start degrading the starch that they have applied in the second part on the sizing here. And then pre-treatment, depending on the type of fibers that we have. For example, if it's cotton, we are doing mercerizing. Mercerizing is a process of using high concentrated sodium hydroxide for turning this bean-shaped cross-sectional area of like cotton. The cross-sectional area, they're not circular. So by adding so much sodium hydroxide, they will turn into they will expand and they will turn into semicircular shape, right? That will increase their water absorption, dye absorption, and also the luster of the fabric. So this is a process, and then they should wash it. So sometimes washing and mercerizing for cotton happens at the same time. If we are using synthetic fibers, so they have less pollutants, so that can be just, we can use normal detergents, non-ionic or anionic detergents for washing them. And then we talked about some of the chemicals for dyeing, but definitely we have many more for the printing and finishing. So I have just listed some of these chemicals that are used, for example, for fiber production. You can see anti-static agent, emulsifiers, many different materials can be used here. For warping process, again, some macromolecular can be used. Sorry, these two should be actually here. Right, so this is sizing. So as you can see, there are many additives, deformers, wetting agents, and that's for strengthening the yarns before the weaving process. And then for desizing, you see the enzymatic degradation. Enzymes are sold, different types, wetting agents, and so on. And then for pre-treatment, there are mostly surfactants, detergents, emulsifier. Many chemicals are used here, and also so that's not just dyeing process that is causing the pollution. So the whole process, the chemical processes, they contain many different pollutants that they will be somehow mixed and discharged.
I was interested in one of the questions here in the chat. It's about low-hanging fruits from current machinery. What do you see could be sort of adapted in the current machinery? as a sort of tip, how can our members influence their suppliers? This and this and this you should do first.
I mean, generally, based on the demand of like the customers, the suppliers, the one that they're producing, they will adapt, right? So, for example, if in EU we are saying that we will not accept any like metal complex or mordants, for example, on the samples, eventually we cannot influence like China or India in a short term, but eventually if they see that they should like export to EU and there are some regulation, they adapt themselves, right? So this is one way by like regulation and policy maker. And eventually it will happen if we are visionary and we have this vision that we should have like sustainable green processes. So one way is like by policy making, saying that this will be banned. Like recently, Anna Karin sent me like some report that's actually Sweden is gonna have like tax on like some of the products that they contain like metal. So the whole idea is that there are some visionary people there, policymakers, they want to somehow send this message indirectly to actually the producers in China, India, and other large companies that are producing actually textiles and clothing, say that, look, we will not accept this. This is getting like the penalty is high. So they want that the people, the Swedish people that are going to import those products, they will transfer this. So indirectly we will influence. So this is a way that actually we can influence. We cannot do anything about how much water or wastewater they are producing and using, but eventually reducing the chemicals can decrease. I can remember, I mean, like 10 years ago, there was a carpet producer in Iran that actually they were providing carpets to IKEA in Sweden. And IKEA sent a group for investigating the place to see if they comply with it, if they have wastewater treatment part or not, and also about asking some question about the chemicals that they were using for actually making the color of the carpets dull. And so the company, I mean, they didn't know anything, so they hired me for a few months, and then I served as like advisor there, a consultant, and I dealt with that. And then they for a short period of time, maybe like 3 months, they installed a wastewater plant because they wanted to have this deal with IKEA still. So they complied with that. So these are like, I see it as like somehow easy way to do. I will not say that let's bring back the whole textile industry here, the whole value chain. That would be almost impossible at the moment, because also the labor cost is very high in Europe. So there is no possibility for competing with those, unless we will automate the process, reduce like chemical consumption as much as possible, then perhaps that can happen. So I see like pigment printing, digital printing as possibility that can actually emerge in Europe, right? It's not the labor cost perhaps is much lower, it's automated, and then it's something that locally you can actually produce and print something with lower pollution.
Do you have more questions related to the different one?
I found a question that just came in. It was a question about maybe using certified dyeing printing can be a useful way to influence this low-hanging fruits. Do you agree with that? Have you looked into like ECOFs or discharge and hazardous chemicals or other programs like that?
I didn't get which question was it?
It was the last question here. Can using certified dyeing and printing be useful to tackle this?
Yeah, that can be one way to do that. By the regulation, I think eventually that will be transferred to the producers. If they see they don't have any chance actually to like export, send like products to EU, then they will change the way that they're produced. But you cannot like force them, like the government, to say, look, you should reduce this and that and so on. We don't have any influence on that country and so on. But yeah, this is what I see. Like if we will make it like the vision that we want production with less chemicals, environmentally friendly. And there is another thing that perhaps I should also talk about here is like the concept of like sustainability. If we should also change our mindset about like the textiles and how we see these things. We are where we are because we wanted to have textiles with the highest wash fastest properties. We don't accept like fading, right? If you buy clothes, you put it in the washing machine and it fades, you will not accept it. That's why they produce like reactive dyes, right? And then so much chemicals and the reaction and so on. Otherwise, for thousands of years, we had used like natural fibers and like natural colorants for dyeing them. And of course, they were fading, and that was acceptable. That was acceptable to use. But nowadays, we will not accept. If you see that, you will tell yourself that I will not buy from this brand anymore because it faded, or give color to other like products in the washing machine. So changing the mindset of people also is another issue. This is what is developed because we wanted best of best. But now we are here, people got used to that, and they want like something that it has a very high wash fastness, light fastness, and at the same time they want it sustainable, right? So it's very difficult now to follow that line. But however, I'm trying my best here as a researcher. I'm going to do this, and I will brief you about some of the research lines that we have in this domain to see. There are some environmental options, but we should also change the mindset of people.
Thank you. We have some questions about specific dyeing techniques.
Mineral dyes, for example?
Yeah, mineral dyes, for example, or also using hypercritical carbon dioxide.
Yeah. So let me share again. Some new dyeing techniques have emerged. So here. So the idea is using like non-water like solvent. So this is something emerging and also in our group. And then based on that, they developed this concept of using like some machineries. You can see these are very large machinery with very thick steel. And I will tell you why they should use such a machinery for dyeing process with the supercritical CO2. The reason is that CO2 is a gas, right? But there is a possibility, even for example, at 40 degrees centigrade, if you can see in this chart, if you increase the pressure, then it will reach to a supercritical region. So it's not distinguishable between gas or liquid. So this supercritical CO2, this region that you see here, it needs lots of pressure. So these are high pressurized like vessels for dyeing process. The interesting thing is that there is possibility that they can dissolve actually hydrophobic materials, because CO2 is also hydrophobic and the supercritical CO2 is hydrophobic. So they are used actually for dyeing synthetic fibers like polyester, nylon, and others with dispersed dyes quite fine. Their downside that I can tell is that these are not good for dyeing, for example, cellulose with like reactive dyes and like direct dyes and so on, because this solvent is not a good solvent for those dyes. Those are very anionic, very hydrophilic, and therefore this is a challenge still. But however, this will completely remove what we call like water and chemicals. So from that perspective, is quite good. But as I told you, the problem is with cellulose dyeing. We are using so much chemicals for cellulose dyeing, and dyeing like polyester wasn't that big of a deal, right? So this really didn't change anything for us. While it's very good, it has a very nice, and now you can see this is image from Dyco. So there are some companies that they're developing, and I think I read somewhere that Nike actually, they have a deal with this company that they're going to produce all their products that mostly are synthetic with this method to have like this brand that is waterless dyeing process, right? But you should be aware of also the limitation that is actually for dyeing cellulose. They have some limitation. The other good things about the supercritical is that when you end the process, you're decreasing the pressure, the CO2 turn into gas, right? So that will be released. Of course, it is harmful, so they should have some other devices installed there to actually capture that CO2. But the good thing is you will end up with a dyed fabric that is dry, no droplet of water there. So CO2 evaporates, so you will have the dyed fabric, and the remaining dye remain as like powder. So this is very good for synthetic dyes. So maybe perhaps I can also elaborate on some of the projects that we are now currently working. So dope dyeing pigmentation is also another way. We have a setup here, that ion cell technology for producing 9-minute cellulose fibers was developed here in our department by Professor Sixta and Michael Human. So now we are thinking about adding colorants to dope because they're using ionic liquid for dissolving cellulose. So we are thinking, and I've suggested actually to add colorants that they can tolerate to this dope, and then we will turn it into these macronese fibers, and the coagulation base is water. This is a common process for pigmentation of polypropylene that actually doesn't absorb any classes of dyes with a melt process. But this is a wet process. That means there's dissolved cellulose in ionic liquid. It's extruded through water bath, that is a coagulation bath, and then we can produce some colored fibers. This will actually omit the need for coloration of textile coloration, following textile coloration. So you need less energy and water. So the limitation, so I should also tell about the limitation, is that it makes the process very complex. It's like impurity for the process, so optimization will be very difficult. Some of these dyes that actually they're water soluble, it leach out during the coagulation, right? And then the fibers normally they're stretched, so the color will change, right? So these are some limitations. But the interesting thing is that some of the companies in Europe, like Lenzing, that's producing a lyocell, and some others, they have already started this process. They are producing colored yarns and they are selling colored yarns to their customers. So this is very nice, and especially this is for cellulose. It has been developed for cellulose. And if we manage to add some hydrophobic colorants there in the process, we will end up with some colorants that they are actually embedded in the fibers, right? So they don't have any tendency to leach out during the washing process. So we can produce colored yarns that they are very resistant against fading by washing. So this is I see opportunity. So we have got a grant, so we have started working on this. Hopefully in 2 years I can update you more about the results.
That sounds super interesting. And we talked about in the chemicals group about dope dyeing for synthetic fibers before, but for cellulose fibers would also be very interesting to.
Yeah, it's very challenging. I can say it's very challenging. We have started. We are facing problem actually for producing fibers because this is colorants. Even 1%, it would be if it change all the properties of that dope, right? And the choice of that, optimizing the process, would be very challenging. But interestingly, I saw that Lenzing has already started this, and they're actually producing this yarn. So the other limitation is that mostly we want fabric. Then someone should buy, for example, these dyed yarns and then turn them into fabrics, and then that's another issue. See?
We have a follow-up question regarding the supercritical carbon dioxide method. A few years ago, there were not so many colorants available for this technique, and it was only developed. No, a few years ago there were not many developed, and only low elastane content in synthetic fibers was working. Do you know if there has been a development of more colorants and more flexible process which can manage higher elastane content?
Yeah, that's a good point. Yeah, the fabrics that they have elastans also, they will be affected here. Actually, the heat setting is also very important because this part is high pressure here. It can change also the properties of the fibers while we are going to dye them. The limitation, as I mentioned, is here is that normally they're using like hydrophobic let's say dyes, and those are dispersed dyes that they don't have any solubilized group in the structure, in the chemical structure. So therefore, this is a very good process for dyeing nylon polyester, as I mentioned, with dispersed dye. So dispersed dyes, I mean, they have like, it's a large class of like dye. So I think there are 1,250 like dispersed dyes are listed in color index, and I believe 60% should be still like in use. Right, so these are good choice for this because supercritical CO2 actually is a hydrophobic, let's say, solvent for dyes. So therefore, it works perfectly fine for this type of dye.
Great. Should we continue a little bit? We have one question about cationic treatment. I don't know if you're familiar with that, but they wonder about the Ecofast. Is this a good sustainable choice for saving water in the dyeing process? To cationize the fiber.
Yes. So I just want to go back to one of the slides. So if you can remember, I talked about the effect of salt here, but here the point is like the adsorption. We said that cellulose, right, it has a slightly negative charge in water in neutral pH. Correct. And the dyes, the direct dyes that actually are used for the process, or like even reactive dyes, they have negative charge. So there is electrostatic repulsion. So negative, it repels each other. Correct? So what if you chemically treat cellulose with some cationizing agent? So these are available. So very good. So you make like a positive charge here. So these are quaternary ammonium here, and chemically bond, right? So there would be very strong electrostatic interaction. So this is negative. Then you can, like similar to what I showed you here. So you will add more and more positive charge that are permanently linked to the structure of, like, let's say cellulose, right? So the negative dyes, they will very strongly bind. So it gives somehow the cationic dye sites that wool has, right, in acidic media, right? So we can do the same for cotton by cationizing the surface. So it would be more or less the same effect. Then perhaps we can also use these acid dyes for the dye coloration. But downside of that reaction is that it's a chemical process that you have already done. So you are adding one chemical process to all this line of processes, right? And those are not environmentally friendly quaternizing agent. We don't have like environmentally friendly quaternizing agent. So what is available is like based on epoxide, that it reacts with hydroxyl, and the acid is also should be neutralized, right? So if someone develops a quaternizing agent or cationizing agent that is green, environmentally friendly, then that would be a breakthrough, right? But so far, I'm not aware of that. I mean, that was one of the projects actually I wrote a proposal on that, but still I'm thinking about like to find an alternative to have like a process. So whatever you see in the dyeing process, it has already been like, you need like sodium hydroxide, you need the epoxide cationic agent. So those pollutants actually in the previous section, they will be introduced to wastewater. Then you have this nice like cationized surface. But the story, I mean, that the companies always tell is from where the product is dyeable. Yeah, the dyeability will enhance a lot, but we should also be aware of what has already happened to that fabric for that pretreatment or finishing, that it gives renders such a like cationic dye sites on the fiber.
Ali, could you please give some more information about vat dyeing? For what material?
That I guess, for the sake of time, actually, I removed it from my presentation.
Which is understandable.
Yes, it was on the slide that I saw. The vat dyeing, these are naturally were available even like 200 years ago, 300 years ago, and they were used actually the I think Egyptians or they had developed this process of using glucose, and they had found some like naturally available reducing agent for turning those like plants that they were extracting from plants to turn this into a slightly local form. So by fermentation or enzymatic reaction, that can also happen. You can dissolve this. So the general structure that they were extracting from indigo, this is a pigment. It doesn't dissolve in water. It doesn't have any adsorption capability on cellulose at all, right? But there is possibility by adding lots of sodium hydroxide and sodium hydrosulfide. This is sodium hydrosulfide that is a reducing agent. This is turn these carbonyl groups into ionates, as you can see here. This ionate, this species is called low-code. This process that is in the vat, it's called vat dyeing. And this has a high tendency actually to be absorbed. What happened? To absorb on cellulose, correct? And this is the picture that you can see here, that the cotton as like a rope dyeing. This is called rope dyeing. That in this vat, they are dipping this inside this high concentration of dye with these chemicals. This species will, it's greenish yellow, and it has a high tendency to be absorbed on cotton. They dip it there, they take it out. Oxygen will oxidize back this structure to the pigment form. Therefore, the dye that it has already diffused inside the fibers, they turn into a pigment. Therefore, the wash fastness properties are really high for, and these are the colorants that we are using for denim dyeing for making jeans. So the synthetic, what you see now in the market is not extracted, actually is what we are synthetically producing, and that was actually invented in 1882. So what you see in the market is not the one that is extracted from the plant. I've forgotten the name of the plant. But actually it's the synthetic ones. But the process is the same. So they are using normally for the warp dyeing, lots of sodium hydroxide and hydrosulfide, turn it into loco, and it will be absorbed on the fibers in oxygen, or adding some oxidizing agent, it will transform back into the pigment on the fibers. This time it has been absorbed, so it will turn into pigment. So the wash fastness properties are really high. But rub fastness properties, because they're pigments, it's very low. So that gives that wash out look of denims. That means by stone washing, so part of those colorants can leave the surface. They're like pigments. The other issue with this dyeing is that the uptake is very fast. That means that just they will have ring dyeing. So outer part of like cellulosic yarns normally will be dyed, depending on the pH. So these are the concerns, but that's actually what we want. We want non-uniform dyeing and also low rub fastness. That's something it's very strange way actually for this type of dyeing is very desired, because we want our denim actually to look like not very uniform, wash out like a surface, some like white and blue colors, to be seen together. Strangely, actually, this is working like quite fine in our favor.
And I think a good follow-up question for that is, we talked a little bit earlier about natural dyes versus synthetic dyes. And
I was expecting some people. So, what are the comments?
Well, we have some. We have questions around this at least. Do you think that the natural dyes will be the future? Do you know if there is any information on synthetic dye versus natural dyes in regard of percent of production products? with hazard classification, toxicity, for example?
There are some papers, so let me just go ahead with this. So natural dyes, I mean, the chemical structures, you can see it's not that much of different from like chemical structure that we are synthetically actually produce, right? So for example, this is anthracene. Naturally happened, right? So there was like microorganism that actually produced this like colorants. So we can produce the same by synthetic route, right? Perhaps also like other. Right. But just imagine that like a price of this, right? If you want to extract it from something that is eatable, like curcumin here, and they have very low substantivity towards like fibers. That's another issue, right? So normally I have like 10 minutes like discussion on this in the class. So I asked my students actually to go and have like discuss about this to list like advantages, shortcomings. And always they come back with the shortcomings that it's a long list of shortcomings compared to the advantages. So advantages is it's natural, then it has a nice name, right? Biodegradable. You cannot say that they are not toxic. Some of them actually they are toxic, but imagine that the toxicity is much lower. And this is something that it's by nature, by microorganism, it has been developed, right? So it's biodegradable, it's sustainable, but it competes with like for the land. We should grow like plants, right? We need to use land that we could have used for production of food, for example, producing like some vegetables, plants that actually they are giving color. Right, like one good example is indigo. Now there is actually a farmer here, interestingly, that I noticed, and now I'm in contact with him. He wants also to write a proposal and get a EU grant for this. So he has started planting this indigo, and this year I think he will harvest. He can produce 200 to 300 kilos of indigo. So he's seeing that this is the future for the fashion and mode, and this is natural, this is good, and he has started like investing from like 5 to 7 years ago. So you see that there is possibility, but I told you about like the production. So the production was now at the moment, I mean, in 2000 was 800,000 tons. Now it's around, I can say 2 million tons, I believe. It should be around 2 million tons. Natural colorants, they are nowhere close to this value. 1 ton, let's say 10 tons, nowhere nearly 2 million tons, right? So they cannot have even 1%, 2% share in the market, unless there is so much like demand. So shortcoming, if I want to just list the shortcoming, the substantivity towards natural fibers like cotton and wool is typically low. Then for fixing this dye, they will not absorb and they will not be fixed very strongly. So the wash fastness is very low, light fastness is very low, because they have not been as like produced to be resistant for a long period of time, right? Nature is producing for some like function there, right? For some specific application, and maybe they mostly for like to be used as medicine rather than dye, right? Then also these will like natural colorants will compete with like natural medicine. So you see the colorants as like dyeing properties are low, therefore they are using so much chemicals to enhance their absorption. They are using toxic metal salts as well for fixing them on cotton and wool, right? So they have the same issue. The textile coloration will not be different if we use natural colorants or synthetic, right? But definitely it will look much nicer, when you say it has been dyed with natural colorants. So we should see some of these natural colorants. I will not say all, like something like indigo, it has a chance to come back and it has a share in the market. And that's the responsibility of actually the designer, the fashion designer, to promote this, right? This is exactly what, there is a brand here, Marimekko in Finland, that got in contact with this farmer, and they're using those colorants for making like some clothes out of that with their brand. They're selling, these are natural colorants from natural farms of Finland, something like that, and they are selling those products, right? This is possibility, but as I showed you, I mean, the share in the market is not high that much, and they have exactly the same issues for the dyeing process as those of like synthetic dyes.
Thank you. We can continue forever. I can sit here all the afternoon. But maybe we have some specific questions before we wrap up. And then we will bring this question with us and come back later, maybe during the webinar in May. But we have a specific question. What is your view, Ali, on colorism? Do you know colorism?
Color what?
Colorism. Maybe the person, Chateau, maybe you can unmute and explain.
Yeah. Are you
Yes,
Color.
I'm
Okay,
here.
I saw that. I would want let's.
The reason why I'm asking is because I would like to know myself. So I don't have so much to add to the question, but I know that I think there are some members that is actually using it. But I would like to know more and get someone that to tell me a little bit more insight about the technique itself.
Will you bring that with us and come back to you, Maria?
That would be lovely. Thank you.
Yeah, I don't really know. This is the first time, and it looks like a brand or trade name.
They are adding something prior to the dyeing process, and they claim that by adding this, they reduce the need of water and chemicals and so forth. But I'm a little bit I don't buy everything that I hear, so I would like to kind of
I can
benchmark it.
Yeah, so let me just investigate that further. That's the first time I'm searching a lot, to see if something's emerging. But that's good. Thank you to bring it into my attention. So I will definitely, investigate this further.
Thank you so much.
So we had about, what did I read? Mineral dyes. I lost the question, Mikael.
Yeah, we have several good questions left, but limited time. But I think another interesting question was about the possibility to recycle dyes from wastewater treatment plants. Is that something that's been implemented?
I can just say that it's very challenging. So because look what I showed you on that slide, that the chemicals that normally are used during the textile process, the wastewater are often mixed with each other, right? So you saw that how many chemicals are used in each one. So they are mixed together. Somehow it will be diluted because washing and so on, and sometimes they are actually destruct each other. For example, if you have some oxidizing agent or reducing agent, it will be mixed with this dyeing, so it's beneficial for them. And then they will treat them, but there are certain treatments, so there are chemical treatments, biological treatments, advanced oxidation as well, they to just destruct whatever is there, and also one membrane filtration. One way to reclaim the dyeing is that not mixing it with other wastewater or waste streams, and use the membrane technology to filter those dyes, right? But then again, we have an issue that we have a mixture of colorants, and separating these colors from each other, it would be very difficult. Perhaps one company that is offering or producing dyeing machine, it can have a sort of dye reclamation joint with this machine. So as soon as the dyeing process is ended, so it will filter the same dye batch and then actually get that colorants back, whatever that 10% or whatever it is. But that will increase the price of the cost of the production a lot. Right. So generally, what I have seen is that these are all mixed, and then they are treated with biological, chemical processes, and normally they are destructing the colorants. So by a strong oxidizing agent. They can break the chromophore, and it becomes like colorless. But that doesn't mean that it's less harmful. Sometimes actually by breaking those structures, more byproducts that they are more toxic and more harmful will be produced.
Yeah. Maybe one final question. Are there any environmental concerns to think about when using mineral dyes?
For textile dyeing, we don't normally using like mineral dyes that much because may perhaps as like pigments, that's the only possibility that I see. Maybe for printing they can, but for dyeing we need like organic structure with certain solubility in water because the media is normally is water. So normally these are aromatic structure or colorants that are used in the market. So I'm not aware of like a huge like share in the market for like mineral colorants except for like pigments, perhaps for pigmentation and so on. Even in the textbooks, if you see, you don't see any sign of like those like colorants as a class of dye for textile coloration.
Thank you. Can I have one more question and then I will let you go, Ali?
Sure. We can continue. But I see that
so long, but this is so interesting.
people got tired now. They're leaving.
I know. I don't. No, I'm just kidding. What do you know about quinoline? Is it commonly used in the dyeing process?
Quinoline is dye intermediates. It doesn't actually have color. I think it's one of the intermediates that is used by coupling with other like species for producing color. There is possibility. It's aromatic structure, but it's colorless. The conjugated system is not that long. I believe that will be used for coupling with other like intermediates for producing colorants.
Thank you. So, should we wrap up here?
I think so.
And thank you so much, Ali. It has been really interesting. What we will do is that we will take care of these questions, and we will try to come back to all of you that we haven't been able to answer. And we will also have the wrap-up session in May, and you will get an invitation sent out by email in the next coming weeks about that.
Very good. Okay.
So,
thank you
so much, Ali.
bear with me, listening.
Thank you. It was very valuable. Thank you.
Great. Have a wonderful evening.
You too.
Same to you.
You too. Thank you.